This is like one of the great moments in modern science.
I really think it is. It's certainly the moment that people who know who Dick Alexander was reference as sort of the high watermark because it's comprehensible. You know, Dick did a lot of things. He was very interested in people and other things, but this particular demonstration was so, it would be impossible to have predicted such a thing and have gotten lucky.
Now, Dick Alexander is a legend in evolutionary theory because it's very hard to use evolutionary theory to make predictions that can be verified in the world. It's sort of like this loose, amorphous collection of techniques and viewpoints, and people sometimes think it's not even a theory because it doesn't seem to be predictive. And then there are a few predictions. So am I right? Darwin started this game off by predicting that there would be a moth with a really long tongue because there was a flower that had a really long distance to go before you could get the nectar out of it.
Yeah, he had been sent an orchid by Bateson, maybe, with a foot-long corolla tube. And he reasoned very straightforwardly that it would make no sense for this plant to have invested in this very long structure if there were not a tongue that could reach down to gather the nectar. And I believe he did not live to see the discovery of that animal.
I didn't know that.
But he was absolutely correct. There is a moth that has this beautifully long tongue. It's a sphingid hawk moth, one of these sort of hummingbird-esque moths. And anyway, yeah, it's one of the major predictions, demonstrations that evolutionary theory actually can be used to predict phenomena that you haven't been able to observe.
Okay. And, you know, Darwin famously couldn't, for example, like, I don't know how much I've talked about this in the open, but my favorite Darwin book is the one he wrote after Origin of Species, which is on the various contrivances by which British and foreign orchids are fertilized by insects. It makes absolutely no sense as a title because I think that's what's so funny about it. But because orchids are so highly speciated, it turned out to be the perfect place to explore the consequences of evolution. And he couldn't figure out my favorite, I don't know whether it's clade or group of...
Clade's pretty safe.
Yeah, clade of orchids, the Ophrys system, which is just unbelievable because it mimics the pollinators, the female of the pollinator species using pheromones and some sort of replica good enough to fool males into copulating with the lower petal of an orchid. It's astounding.
3D replica of the female that smells like her, and it just so happens that when the male lands on it to copulate, he gets these pollen packets glued to him, and then he screws up and makes the same mistake at another flower and delivers.
Well, he may or may not.
Let's put it this way.
But only the ones that screw up twice get to fertilize.
The reason that it gets glued to him is that it has worked enough times for this strategy to have been so beautifully refined.
Right. So Darwin saw that there was this mimicry going on, but he couldn't put it together. He spends pages and pages not getting it. So I think it's very funny. So he predicts some things, but he can't predict something else in a very closely related system. Okay. Fast forward, Dick Alexander comes out with a crazy prediction, which I still don't fully, it's just amazing that he made it, where he says, I bet that you will find the kind of behavior we associate with wasps and bees, which is in this clade called Hymenoptera, and ants, of eusocial breeding patterns and organization, but in mammals that will live underground.
So I think the way this story actually worked, he didn't say you will find it.
Or you could find it.
What he said is, in principle, there's no reason that a eusocial animal has to be an insect. That, in fact, you could get such a thing in a mammal. And then he predicted, I forget how many characteristics there were, but he named some
So we
large...
should say that there's something funny about the system of ants, bees, wasps, which is that they've got this very strange haplodiploid chromosomal characteristic. Do you want to say a word about that? Because that makes the prediction more
Sure.
astounding.
So it has long been understood that the Hymenoptera behave in this incredibly cooperative fashion in which effectively all of the workers of the colony forego reproduction in order to advance the reproductive interests of the queen. And it was late discovered that actually their genetic system is unlike our genetic system, and that males have basically half a full complement of genes. They have enough genes to function, but they have half the female complement of genes. And for reasons that are mathematically slightly complicated and require a chalkboard, the females are more closely related to the daughters produced by their mother than they would be to their own offspring. They're 3/4 relatives to her offspring, and they would be 50% relatives to their own offspring.
Spot on.
So they are actually evolutionarily favored by very standard mechanisms. Once you understand the crazy genetics underlying the thing, they are favored to engage in behavior where they forgo reproducing and foster.
So that once you understand the chromosomal difference of this system, it is far less surprising that it would behave as a loosely coupled, in some way, don't overreact, unified organism, which is distributed, that there's a way in which, and there are ways in which the hive behaves as a superorganism, and there are ways in which it does not.
Yeah. Well, all I want to say is I'm not sure how clear we have the story with respect to what precedes what. It's completely plausible that the behavior precedes the evolution of the genetic system.
Right.
And I actually, frankly, just don't know where that research stands at the moment. We have found many other insect systems that have various versions of this. Interestingly, though, the termites are not hymenopterans.
Right.
And the termites engage in this behavior.
Termites are eusocial, but they're not haplodiploid.
They're eusocial. They behave very much like ants.
Okay.
But they don't have the strange genetic system, proving that the behavior can evolve even in the absence of this genetic system.
Well, the reason I bring this up is that if you look at, for example, Prince Peter Kropotkin, the great anarchist theorist, he was obsessed by finding analogs in nature of preferred human structures. And so it's very simple to say, why can't we work together the way an ant colony all works together? And then there's a counter to that, which is, well, they have different chromosomal structures. And then you say, well, but that's a kind of a cheap way of achieving eusociality. There are other ways of, so we, through this crazy kind of, investigation, we get to Dick Alexander, who, and I think you're quite correct, says, there is nothing prohibiting us from finding a mammalian species that exhibits ant and wasp-like behavior. And it would be likely to have these characteristics. It would live underground underground. I believe eating tubers was on the thing. It was a crazy list of things. And, my understanding from Dick is now unfortunately dead. He died a couple of years ago. But, my understanding from him was that he didn't actually expect to find such an animal. He was speaking very abstractly, just completely theoretically. And at the point that he unleashed this idea, it may even have been in a talk rather than a paper, the information made it back to him, actually, what about naked mole rats? They match your characteristics. And study reveals then that actually they are eusocial. They behave very much like ants, bees, wasps, termites, etc. And this is like one of the great moments in modern science.
I really think it is. It's certainly the moment that people who know who Dick Alexander was reference as sort of the high watermark because it's comprehensible. Dick did a lot of things. He was very interested in people and other things, but this particular demonstration was so. It would be impossible to have predicted such a thing and have gotten lucky. He had to have understood some things that were extremely deep in order for that to have worked out. And so, yeah, it's really, I don't know of another example in evolutionary theory of a prediction that clean of something that obscure.
I know one.
Oh, yeah.
Yeah. I once heard a story about, a graduate student who predicted that the breeding protocols of laboratory rodents would compromise the laboratory system in terms of its relationship to so-called wild type versions of the same species. So you have the bred rodents and you have the wild rodents, and that they would be distinguished by virtue of the fact that the non-coding nucleotide sequence at the end of the chromosome, known as telomeres, would be wildly different in length if the prediction were true from pure evolutionary theory.
Wow.
Yeah.
Yeah. Yeah, that story, it didn't happen exactly the way you said it, but, it's been a lot of years and it takes a second to get back there.
Yeah, I mean, it's you did that.
Yeah, I did that.